Hello guys, welcome to another video. This one is paper 1-3 of May-June 2020 for Pure Math paper 1. So let's move on to question number 1. So find the set of values for m for which the line y equal to mx plus 1 and the curve where this equation meets at two distinct points. So whenever you see this, the first thing should come to your brain is b squared minus 4ac is more than 0. That's the first thing you need to think about. So the next step is as always, we have to solve these two simultaneously. So here we have y and here we have y. So replace, you will have mx plus 1 on one side equal to 3x squared plus 2x plus 4. Now we have to regroup every term together. Let's send this one on this side. You will have 3x squared plus 2x minus mx plus 4 minus 1 equal to 0. That becomes 3x squared minus, you factorize x outside, you will have, so plus here, 2 minus mx plus 3. So now, as you observe, this will be your value for a will be 3, b will be 2 minus m, and c will be 3. Now we have to use this fact, b squared minus 4ac. So we have to find the critical values. So critical values is b squared minus 4ac equal to 0. So this is for later on. For now, we just have to use this to find the critical values. So b squared will be 2 minus m squared minus 4 times a times c equal to 0. Now that will become 4 minus 4m plus m squared minus 9 times 4 will be 36. Now you can simplify, that will become m squared minus 4m minus 32 equal to 0. Now you can factorize this equation. That will be a simple quad equation. So m here. 32 is 4 times 8, so you write 8 here and 4 here. To become minus 4, we have to do minus 8 plus 4 to become minus 4. Now m will be equal to 8, m will be equal to minus 4. So those are the critical values for m. So now let's look at the curve. The curve is m squared minus 4m minus 32. It is a positive, so you know the shape of the curve will look like this. Now we'll have a line here, and the critical points will be these two. This is minus 4 and this will be 8. Now coming back to the first point, we have to know where it is more than 0. More than 0, it is above this line. So it will be this region and this region, which is more than 0. So your answer will be m needs to be more than 8 and m needs to be less than minus 4, where these two will be more than 0. So the set of values for m will be m more than 8 and m less than minus 4. And this is your question number 1. Question number 2, the equation of a curve is such that dy by dx is equal to this. It is given that the point lies on the curve. Find the equation of the curve. So basically what it means is, equation of the curve is to find the value of y from this. This is the point x, y, right? So we should know by now y is equal to integration of dy by dx with respect to x. So let's do that. So y is equal to integration dy by dx, so 3 minus half dx. That will be 3 plus 1, that will be 3 over 2 minus 3 plus 1, that will be half, divided by half. And now of course you have to plus c for the constant of this integration. Now if you simplify, that goes away. You will have 2x 3 power 2 minus 6x half plus c. That is y. Now we have to find the value of c. So we have to use this point. This point says 4, 7. This is your x and this is your y. So x replace here, y replace here. That will become 7 equal to 2 times 4, 3 power 2, minus 6, 4, 1/2, plus c. Now let's simplify. So we can just use our calculator here to make our life easier. So 4 power 1.5, that is 8. So 2 times 8 minus 6 times 2 plus c. So 7 equal to, this is 16 minus 12 plus c. 7 equal to, this is 4 plus c. So the value of c will be 7 minus 4, that is 3. So from this, we will know our equation of line. So y is equal to, of the curve, so 2x 3 over 2 minus 6 x half plus 3. So this should be the equation of your curves. So let's double check the integration. So that will become plus 1 will become 3 over 2 divided by 3 over 2. 3 cancel, that will become 2, good. And this one becomes minus, so plus 1 first becomes half, divided by half become minus 6. Okay, so that will be your equation of curve, and that is question number 2. Now let's move on to question number 3. We have in each part of A, B, and C, the graph shown with solid lines has equation y equal to fx. Good. The graph shown with the broken lines is a transformation of this one. So part 1, state in terms of f the equation of the graph shown with the broken lines. So as you can see clearly that this is just a reflection in this line in the y-axis. So basically y will become f minus x. This will be part 1. So what happens if you have a reflection in the x-axis? It will become y minus fx. So this is something good to know. When you have a reflection in the, this is x-axis, and this one is for y-axis. This is good to know where to put the minus sign for each kind of reflection. Now for part B, state in terms of f the equation of the graph shown with the broken lines. So as you can see, this is my initial curve. It became this one. So this distance here is 1. It became, so we have 1, and it is now 1, 2. Now it was 1, 2. It became 1, 2, 3, 4. Same thing. It was 1, 2, 3. Now it is 1, 2, 3, 4, 5, 6. As you can see clearly that it is a stretch in this direction by a factor of 2. So your curve will be, y will be 2fx. Okay, now for the part C, it says that same thing, equation of graph as shown. So first you can see it moves in this direction and then down. So for it to move to the left side, we have to plus. So first step, have to move to here. We have to, let's see, so it has to move 1, 2, 3, 4. 4 squares, 4 space. So first step is to move to the left. So x plus 4. So now this point become here. Now we have to move down by 1, 2, 3. It has to be minus 3. So your answer is y equal to fx plus 4 minus 3. So always step by step. So let's say for example you have to move to the right side. If you move to the right side, you have to do x minus the value, and now if you move up, has to plus the value, whatever constant you have to move. So you have to count and see what is the movement. So moving up the y-axis will be plus, moving down the y-axis will be minus, but moving right to the x-axis will be minus, and moving left to the x-axis will be plus in that case for the graphs. So this will be just a simple question for number 3. Now let's move on to question number 4. So it says expand this function in ascending powers of a up to and including the term in this. So let's do this one by one. The first term will be 5, 2, 0, first term. Second term, this is 5 and this is 0, plus 5 choose 1, 1, a, that will become 1 here, that is 4. 5 choose 2, 1 and a, that becomes 2 and this becomes 3. And last term, 5 choose 3, that becomes 1, a, and that becomes 3 and 2. So we have to stop at a power 3. Now if you simplify, this is just 1 times 1 times 1 plus 5 times 1 times a plus, so what is 5 choose 2? I think it is 10. Let's check. Yep, it is 10. So 10, choose 1, choose a square, times a square, sorry. And then this is 10 as well. Let's check. 5 choose 3, 10 as well. Good. And this will be 1 and this will be a3. So simplify, 1 plus 5a plus 10a square plus 10a cube. So this will be your expansion. Now for part B, hence expand this one in ascending powers of x, including the term in x power 3. So we just have to find the terms before this and until this. So we don't need anything afterwards. Okay, so if you observe, a1 plus a power 5 was the one that we have here. So we have to use this to equate this. So plus x plus power 2 power 5. Now if you observe, you will see that a here is the same as this one. So what we do, we replace a by this value. So let's do that. So in the initial expansion, we had 1 plus 5a plus 10a square plus 10a cube. So the first term will be the same, obviously. So 1 plus 5a, a will be this one, x plus x square, plus 10, what is a square? A square is x plus x square power 2, that will become this, and x power 4. So that will become 10 times x power 2 plus 2x power 3, and we don't need power 4 because we only need the term until x power 3. Now plus, what is a power 3? It is a power 3 is just a power 2 times a. So it will be 10 times a power 2 is this, x power 4. So we don't need that, but let's write this down for now, and that will be x plus power 2. Okay, so if you expand, you will have 1 plus 5x plus 5x square plus 10x square plus 20x cube. And now plus, so for this expansion, we just need this times this, because this is the only term that we need, which is 10 times x power 3, and the rest we don't need because it will be more than 10, more than the power will go up. We don't need anything more than this, so that's why we don't need the other expansions. Now let's simplify. That will become 1 plus 5x plus 5x square, that becomes 15x square plus 20x cube plus 10x cube. So simplify, you will have 1 plus 5x plus 15x square plus 30x cube. So you just need until this expansion, and this will be your answer for question number 4. Okay, let's move on to question number 5. It says the diagram shows a chord going around a pulley and a pin. This is the pin and this is the pulley. The pulley is modeled as a circle with center O and radius 5. Center O, radius 5. Okay. The thickness of the chord and the size of the pin can be neglected. Good. The pin is situated 13 centimeters vertically below O. As you can see, the pin is here. O is here. It is exactly below by 13 centimeters. Now, point A and B are on the circumference of the circle such that AP and BP are tangents. So these two are tangents. As you can see, they have 90 degrees on the angle. Now, the chord passes over the major arc AB of the circle and under the pin such that the chord is taut. Taut means it is really pulled. Okay. Now the main question is to find the length of the chord. So the chord is this thing, this line, which is bold line. So we have to find the length. So as always, we have to break it down into parts. So first length we can find is, we can find this length. We can find AP. So let's find the length of AP first. Number one, AP is equal to what? So by observation, AP can be found by using the Pythagoras theorem, because we have a right angle triangle here. We have these two sides, we can find this side. So you would say 5 square plus AP square equal to 13 square. So from this you will have AP square equal to 13 square minus 5 square. So AP square will be what? So let's do that. 13 square minus 5 square, that will be 144. So from that you will have AP equal to 12. So AP is equal to 12 centimeters. Now since AP and APB are the same, this is 12 and this is also 12. So now the next step is, what we can do is we can find this angle. This is the same side, obviously. We can find this angle here, alpha. This also will be alpha. So how do you find alpha? As you observe, we have triangle AOP, which is a right angle triangle, and you can find the angle pretty easily. So let's find alpha. Number 2, alpha. Alpha will be found by using SOHCAHTOA. So we have this side and this side. This is our hypotenuse. This is the adjacent side, so we can use cos. So cos of alpha is equal to 15 over 13. From this, alpha will be cos inverse of 5 over 13. It is not 15, it is 5 over 13. So let's find out the angle. So we can just use radians in this case, radiant. So cos inverse of 5 over 13, that is 1.176 for the angle of alpha. Now, what is this angle together? Let's call this angle alpha plus alpha is equal to theta. What is theta? So times 2, that will be 2.352. Now, the angle we want to find actually is this one. What is this angle? It will be 2 pi minus alpha minus alpha. Let's call this one angle beta. So number 3, find beta. Beta will be 2 pi minus theta. So 2 pi, that will be 3.93117. Okay. Now we have to find the length of AB. As you can see, AB is an arc. So AB, now moving on to part 4, find the length of AB, which is arc AB, which is equal to r times theta. Now r radius is given to us as 5, theta we just found out it was, sorry, not theta, but this angle here, we have to use beta because the angle is beta in that section. That will be 3.93117. So times 5, that will become 19.65587. Okay, so if you observe, we have this length as well, which is 19.65587. So now what is the length of the chord? It will be PA plus AB plus BP. So the length will be 12 plus 19.7 plus 12. That will give me 12 plus 12 plus answer, that will be 43.65587. You can just write 43.7 centimeters for the length of the chord. And this is question number 5. Let's move on to question number 6. A point P is moving along a curve in such a way that the x-coordinate of P is increasing at a constant rate of 2 units per minute. So it tells you that dx by dt is equal to 2 units per minute. That's what we have from this information. Now the equation of the curve is given by this. That is good to know. So part 1, find the rate at which the y-coordinate is increasing when x equal to 1. So we have to find dy by dt when x equal to 1. So now the thing we can do here is we can play with this formula. So dy by dt is equal to what? It is equal to dy on top times dt on the bottom. So what relates these two together? That will be dx and dx. So this we know already. Dx by dt has been given to us as 2. So we have to find dy by dx. So since we know that y is equal to 5x minus 1 power half, we can find dy by dx at x equal to 1 pretty easily. So let's do that. Let's do dy by dx first. That will give me half 5 minus 1 power minus half times 5. That becomes 5, 2, and we have root of 5x minus 1. This is dy by dx for the curve. Now we have to replace the value of x by 1. Let's see, dy by dx, what we have? 5 over 2. So 5 minus 1 is, so 1, 5, 4, that will be 2, which becomes 5 divided by 4. So dy by dx equal to 5 divided by 4. Now we can replace this back in the equation. So dy by dt is equal to 5 over 4 times dx by dt is 2. That will become 2 here, 5 over 2, which is 2.5 units per minute. This is your rate of change of the y coordinate. That is question part 1. Now let's move on to question part 2. It says to find the value of x when the y coordinate is increasing at this rate. So as always, what do we know? We know that dy by dx is equal to 5 over 2 root of 5x minus 1. And we know dx by dt is given by 2. And we know now that dy by dt is given by 5 over 8. So we have to find the value. We have to find the value of x. So how would you find that? So let's play with the formulas to see what do we need to find. So how do you find dy by dt? It is equal to dy by dx times dx by dt. Now dy by dt is equal to 5 over 8. Dx by dt we don't know. We just know the equation, but let's write down dx by dy by dx and times dx by dt is 2. So from this we can find the value of dy by dx. That will become divided by 2, 5 over 16. This will be your value for dy by dx. Now we can replace this on this side and this to solve to find the value of x. So we know this is equal to this equation right here. So this is equal to 5 over 2 root 5x minus 1 equal to 5 over 16. So these two cancel out. 1, 1. This becomes 8, 1. So we have 1 over root 5x minus 1 equal to 1 over 8. So the next step is to cross multiply. You will have 8 here. You will have root of 5x minus 1. Then you will have, send this one over here, becomes 64 equal to 5x minus 1. So 5x becomes 65. X becomes 65 divided by 5, which is 13. So your value of x will be 13. So x equal to 13 at dy by dx equal to this value. And this is your question part B. That is question number 6. Let's move on to question number 7. Part A, we have tan theta over 1 plus cos plus tan theta over 1 minus cos. You have to show it equals to this. So as always, we start from the left hand side. So let's see what can we do. Since the base are different, we have to do LCM and then cross multiply. You will have tan theta 1 minus cos theta plus tan theta 1 plus cos theta. Now that will be over 1 plus cos theta times 1 minus cos theta. So now we can try to simplify one by one. So what is this? This will become, this is just like a plus b, a minus b, so that will become this 1 square minus cos square. So sorry, this will be 1 minus cos square theta, which is same as sine square theta. And how about the top? The top will become, let's see, if you expand, you will have tan theta minus tan theta cos theta plus tan theta plus tan theta cos theta. So these two will cancel out, so you will have 2 tan theta remaining on top. So let's rewrite this again. You will have, on top you will have 2 tan theta divided by sine square theta. Now you have to know that tan theta is actually equal to sine theta over cos theta. So replace back, you will have 2 sine theta cos theta divided by sine square, so divide by sine square theta. So this one cancel out. Remaining will be 2 over sine theta cos theta. This is shown as required. That is part A. Now let's move on to part B. Let's see what we have on this side. It says hence. So when you see hence, you have to use your answer in part A. Solve this equation. This is, as we have seen, is equal to 2 over sine theta cos theta equal to 6 tan theta. Now if you simplify, you can just divide by 2 here, become 1, divide by 2 become 3, and then we cross multiply, that becomes tan theta equal to 3 sine theta cos theta. Now this one is equal to, as always, you know, it is sine theta over cos theta equal to 3 sine theta cos theta. Next step is to cross multiply. You will have sine theta equal to 3 sine theta cos square theta. Now you can send this one over here. You will have 3 sine theta cos square theta minus sine theta equal to 0. Now instead of dividing sine, we can just factorize sine theta outside. You'll have 3 cos square theta minus 1 equal to 0. So now your two possible solutions will be sine theta is equal to 0, or 3 cos square theta minus 1 is equal to 0. Now you have to solve this. So one by one, this will become sine inverse of 0 is 90. Sorry, it's 0 actually, not 90. It is 0, and it will be 180 or 360. But as you have seen, the range here is only between these two, not including those factors, so that will be outside the range, so it cannot be a solution. Now for this one, cos square theta is equal to 1 over 3. Cos theta is equal to plus minus root of 1 over 3. So for this value, cos theta, for the positive one, root 1 over 3, it will be between this here, which is theta, and this here, which is 2 pi minus theta. So let's find the value of theta. Theta will be cos inverse. So cos inverse of 1 root of root 1 over 3. That is, let's do in terms of degrees. That will become 54.7 degrees, or it can be 2 pi, which is 360, minus answer, which is 305.3. Now for this one, let's say if it was negative, the value of your angle should be in this section, where this is 180 minus theta, and it should be here, which is 180 plus theta. So two values for plus theta. So let's see. So theta here in this situation will become 180 minus 54.7. That will become 125.3. Or it can be, this one is 180 plus theta, which is 54.7. That is 234.7. So now if you check the values, it needs to be inside the range of theta, which is between 180 and 0. So there's only two possible values. So this is outside, this is outside. So this and this could be the solution. So theta is equal to 54.7 and 125.3. This will be the two values of theta that satisfy this equation. This is question number 7. Now let's move on to question number 8. It says the first term of a sequence is sine square theta. So for theta being an acute angle, the second term of the progression is this one. Okay, so part 1, given that the progression is geometric, find the sum to infinity. So we have to find the sum to infinity. So first thing, what is the nth term of a geometric sequence? So un of a geometric sequence is given by a r n minus 1. So first term, it is u equal to 1, which is a is equal to sine square theta. Now the second term is given by sine square theta cos square theta. Now this is second term. We have to find the value for r. So this is equal to a is sine square theta times r, n minus 1 is just 1. So from this, the value of r will be cos square theta. Okay, so what is the formula for sum to infinity? So sum to infinity is equal to a over 1 minus r. The reason why is because r is less, the value will be less than equal, so the magnitude will be less than 1. That's why we can use this formula. So a will be sine square theta divided by 1 minus r is 1 minus cos square theta. That will be sine square theta divided by sine square theta is equal to 1. So sum to infinity will be 1 for part A. Now let's move on to part B. It says that it is now given that instead the progression is arithmetic. So when you have an arithmetic progression, you have to know the nth term is given by which equation. So that will be given by a plus n minus 1 times d. And now the sum of the first nth term is also given by half n of 2a plus n minus 1 times d. So you have to know these two formulas for an arithmetic progression. Now question part 1, find the common difference, so d, find the value of d of the progression in terms of sine theta. So we know already the first term is a is equal to sine square theta according to question. So we have to find the value of d. We know second term is a plus d is equal to sine square theta cos square theta according to question. So we have to find the value of d. So d will be sine square theta cos square theta minus a, which was sine square theta. Now if you factorize this outside, you will have sine square theta, that will become cos square theta minus 1. Now what we can do here is, if you observe, we can factorize minus 1 outside. You will have sine square theta times factorize minus 1, you will have 1 minus cos square theta. Now what is 1 minus cos square theta? It is equal to sine square theta. So if you simplify, that becomes minus sine 4 theta. This will be your term d for the common difference. Okay, so now moving on to part 2. Find the sum of the first 16 terms when theta equal to this. So what is this angle? Theta is 180 divided by 3. It is 60 degrees. Okay, so that's good to know. You don't need to do that, but that's good to know. So we have to find the sum of the first 16 terms. That will be using this formula right here. So half n is equal to 16, 2a, so 2 times sine square theta plus n minus 1 is 15 times t, which is minus sine 4 theta, equal to that's it. Yeah, and let's solve this to see what we have. So here becomes 8. So we will have 8 times 2 sine square theta minus 15 sine power 4 theta. So if you expand this, let's see what we have. You will have 16 sine square theta minus, so what is this value here? 15 sine, so 15 times 8, that will be 120. So 120 sine power 4 theta. So one by one, let's find those two values. The value of theta is equal to 60 degrees. So what is sine square of 60 degrees? Let's replace. You will have sine of 60 square, that will be 0.75. Now what is sine power 4 of 60 degrees? So sine of 60 power 4, that will be 0.5625. Now replace back in the equation. You will have 16 times 0.75 minus 120 times 0.5625. Let's see, what do we have? Times 120, and you will have 16 times 0.75 minus that becomes minus 55.5. So this will be your answer for part 2 of question number 8. Question number 9, the function f and g were defined by those two functions, as you can see here, and for these two domains. Now part 1, express f of x in the form of this, so we have to complete the squares for f of x. So the first step, I like to rewrite down the function again, so x squared minus 4x plus 3. So the first thing I check is, I have to check if the coefficient of x squared is 1. If it is 1, then we can proceed to step number 2. Step number 2 is I rewrite this part, some space, and write plus 3 on this side. So here I write plus, you take this number here, which is 4 plus 4 divided by 2 square. Now when you add something, you also have to minus the same function so that your equation is the same value as before. Now we can simplify. So here we have x squared minus 4x plus 2 square. Now become plus 3 minus 2 square is 4. So now this can be factorized as a complete square. This will be minus 1. So here we have to write x, here we have to write minus, and here we have to write 2. So as you can see, this is in the form of this as required. That is part A. Now let's move on to part B. It is given that f is a one-to-one function. So now if you look at f, usually, as you can see, this is a minimum function, which means f will be having a shape like this from this function. Now, it says that f is a one-to-one function. So what does it mean to be a one-to-one function? So for example, let's say I have a curve which looks like this. A one-to-one function means that if I were to draw a line, a horizontal line, it has to cut the curve at only one point. So as you can see, this curve is one-to-one. But now if I actually cut the curve that we have for f of x, you will see that it cuts at 2 points. So it is usually not a one-to-one function. So how can we make this a one-to-one function? By redefining the domain. So by choosing a value for x to start with, as you can see here, defining the value of x, it can be 1 to 1. So when you have a minimum or maximum curve, usually you will choose x exactly at the minimum point. So here we have to choose x more than this value, c, so that we have a 1 to 1 function. So we have to remove this part, so we only have one side, and when we draw a horizontal line, it is intersecting at only one point and then becoming a 1 to 1 function. So let's find the value for c. As you can see here, state the smallest possible value for c, and as you have seen, it will be the minimum point for x. So now we know that f of x is equal to this function, x minus 2, 2 minus 1. Right. So one trick we know is that the inside of this will help you to find the minimum value of x. You will say x minus 2 is equal to 0. So x will be equal to 2. So when the curve does this shape, the minimum point here is x equal to 2. So the value for c, as you can see here, would have to be c, from this, c has to be equal to 2. Okay, so now let's move on to part c. It says it is now given that c equal to 5. So our function f of x is the same as before, which is x minus 2 square minus 1. Now the domain has changed to more than 5, which is the value for c. Question part 1 is to find f inverse. As always, let y equal to f of x, which is x minus 2 square minus 1. Now, we send this one over here, you will have y plus 1 equal to x minus 2 square. Now, x minus 2 will be square root of y plus 1. Now, since x is positive already, we don't need to put plus minus, go with a positive value. Now, x will be 2 plus y plus 1. So from this, f inverse of x is 2 plus root x plus 1. This will be your inverse of f of x. Now state the domain of f inverse. So as you know, domain of f inverse is equal to range of f. F is equal to x minus 2 square minus 1, where x is more than 5. So what is the range of f? So we can just replace the value here. The minimum value of x in this one will be, let's say it's 5. So that will be, let's say we found f of 5, it will become 5 minus 2 square minus 1, that will be 8. So 9 minus 1 is 8. So from this we can see that as the value of x increases, the value will keep going up, as you can see from this function. You increase the value of x, your whole function will keep going up. So it will look like this. So f, the range of f is more than 8. That's the minimum value for that function. And then now, from this point, since we have range of f is this, domain of f inverse will be your x values. Domain, domain will be, the x values will be more than 8. So remember that domain is the x values and range is the y values. So this is y and domain is the x values. So this will be your answer for part C. Now for part D, find the expression g of f of x and state the range of g of f. So let's first write down both functions. So we have f of x is equal to x minus 2 square minus 1, and g of x is equal to 1 over x plus 1. X more than minus 1, and here we have x more than 5. Now we have to find this function. Gf of x is just g f of x. I hope that makes sense. It will be inside of g. So let's just replace f of x inside of g. You have 1 divided by f of x plus 1. Now the value for f of x is given by x minus 2 square minus 1 plus 1, which will give you 1 divided by x minus 2 square. Now this will be a function for g of f of x. Now we have to find the range of g of x, so range of g of x, gf of x, sorry. So as you can see, now the function gf of x, it depends on the values that f of x can take. As you can see, f of x is x minus 2 square minus 1, where it is more than 5, and the range is more than 8. Right. Now we have to look at this value to see what value f of x can take, so that to see what g can be. Right. So what we can do here, we can say assume, because we have to take the extremities, the extreme values here, assume that x is equal to 5. What is the value of f of x? Not f of x, but this value, gf of x. So 5, that will be 1 divided by 5 minus 2 square will be 1 over 9. That's the extreme values on one side. Now if you observe, we have this function 1 over x minus 2 square, where we know that x has to be more than 5, because as you can see, g takes f of x, and f of x is defined for x more than 5. So as you increase the value of this one, as it go up, so 1 divided by an increasing value of the denominator, what's going to happen? Anything divided by something big, eventually it will approach to the value of 0. I hope that makes sense. So from this we can find the range of g of x. So g of x will be between 0, so it will never be 0, but it will approach the value of 0, and it will be approaching the value of 1 over 9, because as you can see here, it is not including 5, but close to more than 5, but not including 5. So here it was the extreme values, that's why we found this. So it would never be equal to this, but always approaching this. So this will be the range of gf of x. That will be question number 9. Now let's move on to question number 10, part A. The coordinates of 2 points A and B are given as these. Show that the equation of the perpendicular bisector of AB is given by this equation. So first thing we have to see is what is a perpendicular bisector. So basically, let's say we have a point A here and a point B here. We join these two, and the perpendicular bisector is a line that passes exactly at the midpoint at right angle at 90 degrees to the line AB. So first thing we have to find the equation of a line, we have to find the gradient of the perpendicular bisector. So to find that, we have to find the gradient of AB. So what is the gradient of AB? As you know, it is y2 minus y1, so 11 minus 3 divided by x2 minus x1. So let's do that. 11 minus 3 divided by 5 minus 7. That will be 2 over 3. So this is gradient of AB. So from this we can find gradient of the perpendicular bisector. That will become minus 3 over 2. It will be minus of the reciprocal of the gradient. That's how you should know that. Now, what is this point? This is the midpoint of AB. So find the midpoint. Midpoint will be x1 plus x2 divided by 2, and y1 plus y2 divided by 2. So minus 7 plus 5 divided by 2 will be minus 1. Now we have 3 plus 1 divided by 2, that will be 7. So the midpoint is minus 1, 7. So now we have the x and y coordinates. We can find the equation of the line. So equation of the perpendicular bisector, that will be y minus 7 over x minus 1 will be plus 1 equal to minus 3 over 2. Now cross multiply, you will have 2y minus 14 equal to minus 3x minus 3. Now we send this one over here, you will have 3x plus 2y equal to minus 3 plus 14. So 3x plus 2y is equal to plus 11. So this is the same as this. So shown as required. That is part 1. Now let's move on to part B. It says that the circle passes through a point to the points A, B. That's good to know. Its center lies on this line. Now find the equation of the circle. So you have to know what is the general formula of a circle. It is equal to x minus h square plus y minus k square equal to r square, where r is the radius. So r is the radius. So the first thing we have to find out is what are those 2 points, h and k. H and k are the center of the circle. This is your x coordinate and this is your y coordinate. So how would you find this? We have to use this information that we have on top. So it says we have a circle here, for example, and we have the points A and B. So we don't know where it is. Let's just say, for example, it is here, A is here, and let's say B is here. For example, we don't know, it's here. Now we have a line joining A and B, right? Now we have a perpendicular bisector that goes through A and B. So one important thing you have to know is that the perpendicular bisector of a chord will always go through the center. That's a good thing that we need to know. So the equation of this line is given by 3x plus 2y equal to 11, sorry. Now another information we have is this line goes to the center. So this line will be going about like this, but it goes through the center. It means that the intersection of those two lines will give you the center of the circle. So this is the line, 12x minus 5y equal to 70. So we have to solve these two simultaneously to find the center of the circle. So let's do that. So here we have 3x. We can make 3x the subject of formula. That becomes 11 minus 2y. That's equation number 1. So here we have 12x. So 12x is 4 times 3x minus 5y equal to 70. So now you know the value for 3x is equal to this. So 4 times 11 minus 2y minus 5y equal to 70. Now let's simplify. We will have 44 minus 8y minus 5y equal to 70. This is minus 13y equal to 70 minus 44. So let's find out. That will be 26. So y will be 26 divided by minus 13. That will be minus 2. Now value for x will be what? X will be from the first equation, 11 minus 2 divided by 3. So 11 minus 2 times minus 2 divided by 3, that will be 5. So your x coordinate is 5 and your y is minus 2. So this is your h and k. Okay, so now we have to find the radius. So how would you find radius? You can use any point. So let's use the point A, which is 7, 3. And we have the midpoint, let's call the center, let's call it C. That will be 5 minus 2. So what is the distance of AC for the radius? So first thing we can just find the vector AC. That will be 5 minus 2 minus 7, 3. That will become 12 and minus 5. Now what is the length of AC? That will be square root of 12 square plus minus 5 square, which will be, let's find out, 12 square plus 5 square, square root of that will be 13. So the length of AC is equal to 13, which is the radius. Okay, so now we have all the information that we need to replace back in the equation. So here we have x minus h, which is minus 5 square plus y minus k. So minus k, so minus k here is minus 2 square equal to radius square, 13 square, which is equal to x minus 5 square plus y plus 2 square equal to 169. So this will be the equation of the circle that passes through A and B, and also having this line passing through the center. So that will be question number 10. Let's move on to question number 11. The diagram shows part of the curve with equation y equal to this, right? And the line OA, as you can see, we have a line OA here. This is the point A. A is what? Is the maximum point of the curve. The x-coordinate of A is equal to small a. Now, the curve also has a minimum point at this point right here. Now, part 1 show that B is equal to 3a. So now, A and B, as you can see, they are all part of this curve, but this is the max point and this is the min point, which is a stationary point. So what do we know about a stationary point? We know that at stationary point, we know that dy by dx is equal to 0. So let's do that. What is dy by dx of this curve? It will become 3x squared minus 4bx plus b squared is equal to 0. Now let's factorize this. You will have 3x times x, b squared is just b times b. Now to get minus 4, you have to do minus 3 minus 1. Now value of x will be b over 3 and x will be b. So now if you observe, one of the values of x needs to be this and one will be b. So b will be b right here, which is x equal to b, and this one will be equal to b over 3, which means a is equal to b over 3. So from this we can write down a is equal to b over 3, which means that b is equal to 3a, which is shown as required for part 1. So now the one thing we can do, we can find the coordinates of a. Here we have a, and what is the y value? Replace back in the equation. So equation is given by y is equal to x squared minus 2b cube plus b squared x. Now for x equal to a, find the value of y. That will become a cubed minus 2b, b is equal to 3a, times a squared plus b squared is 9a squared times a. That will be equal to a cubed minus 6a cubed plus 9a cubed. Now this one gives you the value of what? So 1 minus 6 plus 9 will be 4a cubed. So the point A is a and 4a cube. Okay, so let's move on to question number B. It says, show that the area of the shaded region between the line and the curve is this, where k is a fraction to be found. So how do you find this area? If you observe, it will be area under curve between this and this minus area of triangle. This is the right angle right here. So how do you find area of triangle? If you observe, half times base, which is a, times height, which is 4a cubed. So let's first find the area of triangle. Part 1, area of triangle. Half times base, which is a, times height, 4a cubed, which gives you 2a power 4 for the area of triangle. Now we have to find area under the curve for this limits with these 2 points minus area of triangle to find this area. So let's find the area. Part 2, area under curve. That will be integration of the limits between 0 and a of the curve y by dx. So as you know, y is equal to x power 3 minus 2bx power 2 plus b squared x dx. Now from part 1 we know that b is equal to 3a. That is from part 1. Replace back, you will have integration of a, 0, x power 3 minus 2 times b will be minus 6a x squared plus b squared, that will be 9a squared x dx. Now if you integrate that, you will have x power 4 divided by 4 minus 6a power 3 divided by 3 plus 9a squared x power 2 divided by 2. Limits between a and 0. Now we place back in the function. In this function, first one will be a. We'll have a power 4 divided by 4 minus 6aa, so that will be a power 4 divided by 3 plus, that will be a squared, so 9 power 4 divided by 3 minus, so if you replace 0 in this, you will have 0 because anything times 0 is 0, 0, 0. That's why. Now if you simplify, this will give you 2, and we can take out, let's take out a power 4. You will have 1 over 4 remaining minus 2a power 4 and then plus 9 over 2 a, so we took out a already, so let's not put a inside because we have a outside. So let's rewrite this down because I don't want to confuse you. So right now we have a power 4 is outside. We have 1 over 4 minus 2 plus 9 over 2. So let's find out what is the value of that operation. Minus 2 plus 9 over 2. That will become a power 4 times 2, 3 over 4, which is 2, 3 over 4, a power 4 units square for the area under the curve. Now going back to the question, we have to find this shaded area, which is area under the curve minus area of the triangle, which is number 2 minus number 1. So 2 minus 1. So 2 is given by this. So 2, 3 power 4 minus number 1 is 2a power 4. That will be 3 over 4 this units square. So this will be your answer for this question, where k is equal to 3 over 4. Okay, so that was the last question of this paper, and as always, thank you for watching, guys. And if you guys have any questions, I will leave a comment down below and I will get back to you.